Betelgeuse, the red giant star teetering on the edge of our galaxy, is sending out some unsettling signals. Astronomers, employing the James Webb Space Telescope, have detected something deeply troubling about this colossal star. Renowned scientist Brian Cox has issued a stark warning. The pressing question is, are we about to witness a supernova explosion so massive it could alter the night sky forever? Let's dive in. In the boundless expanse of the universe, stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of astronomers and the public alike. Betelgeuse, a red supergiant prominent in the constellation Orion. Known for its immense size and advanced age, Betelgeuse has long fascinated observers with its reddish hue and fluctuating brightness. But recent developments have intensified interest in this cosmic behemoth, suggesting we may be on the brink of a monumental event in its history. What do these changes in Betelgeuse mean? Are we on the cusp of witnessing a grand cosmic spectacle? Betelgeuse is a stellar titan, about 764 times larger than our Sun. If placed at the center of our solar system, its surface would extend beyond the orbit of Mars, enveloping Mercury, Venus, Earth, and Mars. This immense size not only highlights Betelgeuse's physical grandeur, but also marks its stage in the stellar life cycle. As a red supergiant, Betelgeuse is nearing the end of its life, expanding and cooling after having converted hydrogen into helium in its core. Betelgeuse is estimated to be between 8 and 8.5 million years old, a brief lifespan in human terms, but ancient on a stellar timescale. Over millions of years, it has transformed dramatically, evolving from a hot blue star to the red giant we observe today. Now, in its final stage as a red supergiant, Betelgeuse's life story is reaching a critical juncture. Stars like Betelgeuse undergo constant changes due to the relentless forces of nuclear fusion and gravity. One distinctive feature of Betelgeuse is its unique reddish color, which stems from its cooler surface compared to stars like our Sun. While the Sun's surface is about 5,500 Kelvin, Betelgeuse's is around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that appear red to us. But this color is more than just an aesthetic detail. It provides crucial insights into the star's physical state and the processes happening within its vast gaseous body. Historical records from Roman and Chinese eras indicate that Betelgeuse was yellow about 2,000 years ago, while 9th century Arabic astronomers noted its red hue. This color shift over human history is not just a fascinating historical tidbit, but also evidence of the star's evolution. Another intriguing aspect of Betelgeuse is its variable brightness. As a semi-regular variable star, Betelgeuse's brightness fluctuates periodically. This behavior has captivated scientists and skywatchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle and a longer 5-year cycle. Sir John Herschel documented these cycles as early as 1836, and Aboriginal folklore may contain references to them that date back even further. However, what truly sets Betelgeuse apart is its occasional deviation from this pattern. Unlike many stars that dim and brighten predictably, Betelgeuse sometimes behaves erratically, suggesting complex and less understood processes at work. Recently, astronomers and stargazers worldwide were taken aback by Betelgeuse's dramatic and unexpected dimming, now known as the Great Dimming, which began in late 2019. One of the brightest stars in the night sky and a prominent feature of Orion started to lose its light at an alarming rate. By February 2020, it was at its dimmest. Betelgeuse, usually visible to the naked eye even in light-polluted areas, became much fainter, noticeable even to casual observers. However, the time paradox complicates monitoring Betelgeuse's activities. Because light takes time to travel to us, we see Betelgeuse not as it is now but as it was about 700 years ago, given its distance of approximately 725 light-years from Earth. This time lag makes it challenging to predict and observe quick changes in its behavior. The Great Dimming event was a stark reminder of how difficult it is to observe the sky in real time and how much we still have to learn about the vast, strange realms of space and time. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored Betelgeuse's celestial drama as part of a 3-year study tracking changes in the star's outer atmosphere. They used Hubble to observe this colossal star, providing new insights into how a variable star like Betelgeuse functions. Variable stars regularly expand and contract, causing changes in their brightness. Researchers were able to peer into the layers above Betelgeuse's surface, heated partly by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Further analysis of Hubble spectra taken at different times in 2019 and 2020 revealed the velocity of material in Betelgeuse's upper atmosphere. The spectra, composed mainly of magnesium and titanium lines, revealed the star's atmospheric conditions. The studies showed material moving from the star's surface into its atmosphere at about 200,000 miles per hour. This hot, dense material eventually traveled millions of miles from Betelgeuse, forming the dust cloud that dimmed the star during the 3 months of the outburst. Dupree and her team estimated that about twice as much material as usual was ejected from Betelgeuse's southern hemisphere during this period. While all stars lose mass over time, Betelgeuse's mass loss was particularly notable due to its rate compared to the Sun's. Astronomers speculated whether this event could be a precursor to a supernova explosion, given the magnitude of the mass release and subsequent dimming. Being only about 725 light-years from Earth, such an explosion would be visible from our planet, offering a rare opportunity to observe a supernova up close. The question remains, what does this dimming mean for Betelgeuse's future? Is it a sign that a supernova is imminent, or is it just a transient event in the star's complex life? Several theories have been proposed to explain this rapid change. One popular theory suggests it might be a stage in the supernova explosion process, given that Betelgeuse is nearing the end of its life. Another theory posits that dust, possibly ejected by the star itself, could be obstructing our view. Betelgeuse and other red supergiants are known to shed material, which could accumulate into a dust cloud thick enough to block the star's light. A third theory considers changes in the star's photosphere, the visible outer layer, which might affect its apparent brightness. Spectroscopic studies showed that Betelgeuse's effective temperature dropped, suggesting the presence of a large dark spot on its surface. This temperature decrease by at least 170 Kelvin around the time of the dimming supports this idea, indicating significant changes on the star's surface. Ultimately, the Hubble Space Telescope, humanity's vigilant observer in space, helped unravel this strange event. Hubble's observations indicated that Betelgeuse's dimming was likely due to a massive ejection of hot material into space. This material formed a dust cloud that obscured part of the star's surface, reducing the light reaching us. It was hypothesized that the dust cloud was made of very hot plasma that erupted from a large convection cell on the star's surface and moved through its hot atmosphere to cooler outer layers. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Betelgeuse, the red monster star on the edge of our system, is sending disturbing signals through space. Cosmologists using the James Webb Space Telescope have uncovered something deeply alarming about this enormous object. Notable researcher Brian Cox has issued a strong warning. Are we about to witness a cosmic explosion so massive that it will forever change the night sky? Let's delve right in. In the vastness of the universe, stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of both astronomers and the general public. This star is Betelgeuse, a red supergiant that stands out in the constellation Orion. It is incredibly large and ancient. Its unique reddish color and fluctuating brightness have long fascinated observers, but recent events have heightened interest in this cosmic giant. As we look into Betelgeuse, we are on the brink of a potentially spectacular event in its history. But what could these changes in Betelgeuse mean? Are we witnessing the beginning of a cosmic show on an unimaginably grand scale? Betelgeuse is a stellar giant over 700 times larger than our Sun. It is so massive that if it were to replace our Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This colossal size not only highlights Betelgeuse's physical grandeur, but also indicates its stage in the stellar life cycle. As a red supergiant, Betelgeuse is nearing the end of its life. It is expanding and cooling during this stage, following the conversion of hydrogen into helium in its core. Regarding Betelgeuse's age, the star is estimated to be between 8 and 8.5 million years old, which is relatively young in human terms but ancient in terms of stellar lifespans. Over millions of years, it has dramatically transformed from a hot blue star to the red giant we see today. Now, in its final stage as a red supergiant, Betelgeuse's biography is reaching a critical moment. Stars like Betelgeuse change over their lifetimes due to the constant pressures of nuclear fusion and gravity. Another aspect that makes Betelgeuse stand out is its unique reddish color. This red hue comes from its cooler surface compared to stars like our Sun. The surface of the Sun is around 5,500 Kelvin, while Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that appear red to us. But this color is not just about appearance. It reveals the star's physical state and the processes occurring within its vast gaseous volume. The fact that Betelgeuse's color has changed over time adds to its mystery. Historical records from Roman and Chinese periods indicate that Betelgeuse was yellow around 2,000 years ago. By the 9th century, Arabic astronomers noted it was red. This color shift over humanity's history is not just a minor scientific fact but also evidence of the star's evolution. Another intriguing quality of Betelgeuse is its highly variable brightness. As a semi-regular variable star, its brightness fluctuates on a periodic basis. This dance of brightness has fascinated scientists and skywatchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle and a longer 5-year cycle. Sir John Herschel documented these cycles as early as 1836, and indigenous folklore may contain references to them that date back even further. However, what truly makes Betelgeuse mysterious is its occasional deviation from this pattern. Unlike many stars that dim and brighten regularly, Betelgeuse sometimes behaves unpredictably, suggesting complex and less understood processes at work within its massive structure. Recently, astronomers and stargazers worldwide were stunned by Betelgeuse's dramatic and unexpected dimming. This event, now known as the Great Dimming, began in late 2019. Betelgeuse, one of the brightest stars in the night sky and a prominent feature of Orion, started to lose its light at an alarming rate. By February 2020, it was at its dimmest. Betelgeuse, normally visible to the naked eye even in light-polluted areas, became much fainter, and even casual observers noticed the change. However, the timing of this mystery complicates monitoring Betelgeuse's activities because light takes time to travel to us. We see Betelgeuse not as it is now but as it was in the past. The light we see today left the star almost 725 years ago, since it is around 725 light-years away. This delay makes it challenging to predict and observe quick changes in its behavior. The Betelgeuse dimming event was a reminder of how difficult it is to observe the sky in real time and how much we still have to learn about the vast, strange worlds of space and time. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely watched the events of Betelgeuse's celestial drama as part of a 3-year study to track changes in Betelgeuse's outer atmosphere. They used Hubble to observe the vast star. These observations provided new insights into how a variable star like Betelgeuse functions. Variable stars regularly expand and contract, causing changes in their brightness. Scientists were able to analyze the layers above the star's surface, heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Further analysis of the Hubble spectra taken at different times in 2019 and 2020 determined the speed of material in Betelgeuse's upper atmosphere. The spectra, primarily composed of magnesium and titanium lines, revealed the star's atmospheric conditions. The study showed that material was moving from the star's surface into its atmosphere at around 200,000 miles per hour. This hot, dense material eventually reached millions of miles from Betelgeuse, initiating the dust cloud that dimmed the star. During the 3 months of the outburst, Dupree and her team estimated that about twice as much material as usual was ejected from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's mass loss was particularly notable due to its rapid rate compared to the Sun's. Astronomers speculated whether this event could be a precursor to a supernova explosion, Given the